Hey folks, okay, well, so far everything we've done in terms of input has been coming from the command, from standard input from the command line, the user typing in stuff. So we've been using cin the whole time to grab whatever the user's typing, stick it in variables or do whatever it is we want with it. But very often we actually want to be able to read from files that exist somewhere on the system, right? If they've got data stored or if they've got configuration files, if they've got spreadsheets for us to read, if they've got saved game files they want us to read, right? There's lots of times when we want to read data from a file, or lots of times where we want to modify a file or to have our program create a new file and write input into it, or write output into it rather. So what I want to do in these next couple of sessions is to look at file input and output. And so we'll take a look at the sort of C++ way of doing things, and we'll also take a look at the C standard I/O way of doing things. Today's we'll do the C++ version. All right, where did I want to go here? So again, we want to read from a file instead of from standard input, instead of from the keyboard, and we want to be able to write to files instead of writing to standard output, instead of writing to the monitor, for instance. And in general, whenever we're working with files, the idea is we get the name of the file somehow, we try and open the file, and it's possible that's going to fail, but because it's possible they give us a bad file name, or it's possible they give us the name of a file that they don't have permission to access. So it's possible that our attempt at open will fail. So we've got to be able to check if it worked or not. Then do whatever input and output we want to do, and then close the file at the end. So that's the general sequence that we're going to follow through. Now, in terms of the file names, those could also include a path on how to get from where you're running the program to wherever the file actually is. So let's say we were, say we're in our lab 5 directory and we were trying to write to a file that was in our labx4 directory. Then we might type in as a file name the .. /labx4/ and the file name. And that tells the program how to get from where you are now to where the file is to access. So sometimes our file names will just purely be the name of a file, and sometimes they'll include a path on how to get from where we are to where the file is. So those are a couple of things to keep in mind. What we're going to focus on is just plain ordinary old text files. So things like our source code files or a text file or in any file that we can create with a simple text editor. So one of the things that we'll be doing as we go through this is to use an editor to create a data file for us to read, or we'll get the program to write a file and then we'll use our editor afterwards to take a look and see if it put the right contents in there. But we really are just talking about plain text files. All right, so the library we're going to be using for the C++ version is fstream. So again, this is going to have provide us with a lot of the same functionality as iostream does, except it also allows us to do things specific to files, like opening the file, closing the file, checking if the file is opened successfully, checking if we've hit the end of a file. So there'll be a few things that this adds for us. So the way we're going to do things, and there are a lot of other possibilities, but the kind of simplest approach that we'll take for now is we'll create a variable of type ifstream when we want to read from a file, and an ofstream when we want to output to a file. So the I for input, the O for output. And these ifstream and ofstream data types are created in that fstream library. So these data types exist somewhere, and what we're going to do is essentially, well, I guess this notion of streams, there's some kind of a connection that we're reading through. So for standard input, there's some kind of a connection from the keyboard to our cin that allows us to read this kind of sequence of things that the user's typing. It's going to be the same idea for files, except they throw this f idea in to designate that this is coming from a file. So we've got an input file stream, some way to make a connection to a file to read from it. Or this notion of an OF stream, some way to make a connection to a file so that we can write to it. So we'll use variables to kind of control these connections. And these are going to take the place of our cins and couts. So instead of doing, for instance, a cout to something, we'll use outfile as the thing we're generating output to. Or instead of using cin to get from something, we'll use infile as the thing to get data from. So it'll get a little more obvious as we get into some examples here. So the idea is we need to know the name of the file for us to be able to open it. So we're going to try and open it using whichever one of these streams we've created. So if I want to open a file for input to read from the file, then I'll say infile.open and then the name of the file. So this can be pretty much any text string. It can be like a bunch of hard-coded text like we show here. It could be a character array that's got the file name in it and a null terminator. It could be a string that's got the name of the file in it. So anything that's got a file name in it we can pretty much pass here. So this is saying, try and open this file. And same idea for output. If I want to write things into a file, I use my outfile.open and whatever the name of the file is. And again, these infile and out files are just the names of the variables that we picked for our ifstream or ofstream. So we pick some ifstream variable name, and then we try and open it and attach it to a file. Or we pick some name for our output stream variable and try and open it, attaching it to, again, some named file. Once we've tried to open it, we'll eventually want to check and see if the open worked or not. But for the moment, let's just assume that it worked, and we'll just focus on using it a little bit. So, tying things back to our command line arguments here, let's suppose that we're going to get the name of the file as a command line argument. So the user can type in something like, ./myprog foo, and then we'll think that foo is one of the file names that we want to read from. So here, I'm going to create the ability to read from a few different files. So infile1, infile2, infile3. Again, these are going to be the variables for my file streams, and I can connect those to actual files for input. So here we're going to say, well, if argc is greater than 1, then they provided a command line argument, and we'll try and open, that should be an infile1. We'll try and open infile1 using argv1 as the name of the file. Maybe I'll try a second one. So this time let's use a string, and we'll prompt the user to enter a file name. So again, we'll create a string to hold a file name, ask the user to enter a file name, cin into the string, and then we'll use the string to try and open that second stream. Or maybe we try and use a hard-coded string. Again, just showing you a bunch of different ways that you can specify file names. So for that third file stream, we'll try and open some hard-coded file name. And again, these can be any plain text files and it'll all work. So we can go through and try and open files in a variety of different ways, or using the file name in a variety of different ways, providing the file name in a variety of ways. Now, again, we have to check and see if it actually managed to open okay or not. So there's a function called isOpen, I guess technically a method called isOpen, that allows us to test if that open worked. So you've got, let's say, your ifstream variable infile, and we're going to try and open that and use some file.txt as our file name. So we give that a try, and then we check to see if it worked. So infile.isOpen will return true if it worked and false if it didn't. So here I'm saying, well, if it didn't work, print an error message, and if it did work, use it however we want, and then eventually we'll close the file up. So we can test to see if it worked or not, and that's something you should always do, because you never know, why. It's always entirely possible that an attempt at opening a file is going to fail. If we try and read from a file that we can't read from that isn't open, then we are going to run into errors. All right, once we've got it open, and we're sure it is open, then we can use lots of different ways to try and read from it. So we can use it kind of like cin, where you can use your infile greater than and some variable, and it will try and read an appropriate value into the variable. There's the getLine function where you pass it the input file stream and pass it some string to read into. So it's going to read an entire line of text from the file into that string variable. Now, with cin, we know that cin keeps track of kind of where it is in terms of reading user input. It's the same idea with these input file streams. As it reads from the file, it gradually works its way through the file. So it remembers where it was in the file the last time it did a read. Right? So each successive greater than, or each successive get line, or each successive fgetc, or whatever other functions we want to use, are going to go through and gradually keep moving their way through this file. Now, we can use the same sort of tests as we did with cin. Maybe x is an int and we try and read it in, and whatever was there, whatever was next in the file wasn't an integer. So it's possible that the read will fail. So we can test it using the same approaches as we've done with cin. Right? We're just using our input file stream instead. Now, if we're reading from a file, if we're reading lots of stuff from a file, it's entirely possible that eventually we're going to hit the end of the file. And sometimes we want to keep going until we hit the end of the file. If I want to read all of the data in a file, then I want to keep reading and reading and reading and reading and reading and doing stuff with the data as I'm reading until eventually I hit the end of the file, and then I want to stop. So there's an EOF function for end of file that returns true after we've hit the end of the file. The one catch is it doesn't realize we're at the end of the, if we read the sort of last data value in a file, it doesn't yet know that that was the last one. It's when it tries its next read that it realizes, oh, I'm at the end. So the way we use the EOF method is, let's say we want to read everything in a file. So I'm just going to read it kind of one word at a time until I hit the end of the file. So I have my do while loop that says, do read some stuff from the file while we're not at the end of the file. So while not in file.eof. And inside, I've got a string variable, and here I'm just going to use the greater than to read whatever the next word is. But it might be that operation that detects that we were already at the end of the file. So I want to throw in an extra end of file test. So a little counterintuitive that we're going to say, well, keep going while we're not at the end of the file, but every time we do a read, we need to check afterwards and make sure that one wasn't the one that actually told us, oh, by the way, you were at the end of the file. So if we aren't at the end of the file after doing that read, then we actually successfully read in a string, and that should be S, not word. So we should be able to print out the word that we just read, the string that we just read. So we can keep cycling through this until eventually we hit the end of the file and bail out of the loop. Now, if you forget to do that, if you forget to check for the end of the file, then essentially the read doesn't update. Right? So whatever value you read in last is the one that you're going to keep getting over and over and over and over again. So if you forget to check for the end of the file, you can wind up with some interesting bugs. And if you forget this kind of inner test here, if I'd left off that inside infile.eof, this would actually wind up showing me the last word twice. So just heads up there. And again, once we're finished, once we've done everything we want to do with a file, we close it back up again. So again, that's just whatever our file stream is, .close. So the basic cycle, again, open it, check if it opened, do stuff, and close it. So for output files, again, it's the exact same sort of idea. We do our out file, or whatever we called our variable, .open, the name of the file in whatever form. If that didn't work, so if it's not the case that the output file is open, then I can give an error message of some kind. Otherwise, I can write whatever I want into the file and then close it up. And the writing is going to work just about the same as with cout. Right? So let's say I've got my OF stream variable, and again, I'm just going to call it out file. I've got some string here that I'm going to use for the file name, and I've got just a float that I'm going to try and write into it. So I'm going to try and open the file, using that file name. If it didn't open, then I'm going to give an error message. And if it did, then here I'm just going to write a couple of lines of output. So I'm going to use the less than to print out a line of text, write a line of text into the file, and an end of line. So the first line of the file will now be, here's my fancy output, and then the end of line. And then the next line will be f is, and whatever the value of f is. So it does work just like cout. It's just that the content is going into the file instead. And again, it's just going in as text. One thing you should know is that if the file doesn't exist, then this will create the file, create a new open file. If the file already existed, then what we're doing here is overwriting it. So you're wiping out whatever it used to be. So this can either create a new one or wipe out an existing one, but it'll be one of the two. All right, let's play with a couple of examples here and see how we go. So what have we got here? Let's try one example where we're going to copy the contents of one file into another. That way we get to open one for input, open one for output, and go through the file we're reading from and keep reading things from it until we hit the end. And as we go, every time we read something, we're going to put it into the output file. So let's take a look at what we've got here. Oops. That's what I get for being lazy. So I'm going to include my IOStream library, my fstream, and my string, and use my standard namespace. And so I'm going to have this copy files function. So I'm going to write this up. It's going to return true if it did manage to do the copy and false if it failed. And it's going to take two parameters for the names of the two files. The source will be the file I want to copy from, and the destination will be the name of the file I want to copy into. So in my main routine, I'll create a couple of strings to hold the file names, get the user to enter them. So, enter the name of the file you want to copy. They'll read that into file 1, enter the name of the new copy, read that into file 2, and then we'll call our copy files function. So that one's going to do all the work. And we're just going to capture the return value from that and see if it worked or if it didn't. So again, it's supposed to return true if it worked and false if it failed. So all of the interesting stuff is in copy files. So again, what we're going to try and do is open the input file, see if that worked. If that went okay, then we'll try and open the output file and see if that worked. And now if we've got them both open okay, then we'll try and copy the contents from the input file to the output file. So I'm going to keep track of whether this is working or not, and I'm going to assume it failed until I actually prove something worked. I've got my ifstream for my input file, and I'm going to try and open that. And again, I'm just using whatever file name they passed as the first parameter. So whatever file 1 was is winding up in source. So I'm going to try and open that file and see if it worked. So I do my check and see if that input file is actually open, then I can go ahead and do stuff with it. And otherwise, I'll print out that message saying, oh, no, sorry, I couldn't open the input file. So if we get past that, if the input file is actually open, then I'll try and do the same thing for the output file. I have a variable for an OFStream variable for the file I want to write into. I'll try and open it using that second parameter, right, the destination file, whatever they called that. And again, I'll check and see if that worked. If the output file is open, then I'm actually okay. I've got both files open right now. And otherwise, I'll give them this error message, couldn't open that output file. And either way, either we kind of give up because we couldn't open the output file, or we go through and do the copy here, and then we'll close our input file afterwards. So, what have we got going on here? For our copy, what I'm going to go through, this time I'm going to go and do one character at a time. Grab each character from the input file and put it into the output file. So again, I've got this loop I want to do while I'm not at the end of the input file, so I keep copying characters until I hit the end. I'll have my character variable, and I want to go from my input file into my character variable. I'm going to use this no skip white space to make sure that it copies the new lines and the spaces and the tabs and all that sort of thing. So we'll make sure we copy every single character. And again, what we'll do is read from the input file into my character variable, and I'll make sure that was okay. If I'm at the end of the input file, then I don't want to write it out. Otherwise, I'll write that character into the output file. So again, that's just my, do while not end of file, and my test after the read, to make sure I'm genuinely not at the end of the input file. And if I got all the way through that, then this should go through and copy every single character in and stop when we hit the end of the file. We'll note that our success is true. Ooh, I didn't close my output file. I should do my outfile.close. Right, so I'll close my output file, and this way I'm guaranteeing that I try and open both files, I check they both succeed, I close both the files if I manage to open them, and I'm doing my character by character copy. And again, eventually returning that success, which I'm setting to true if I did manage to copy all the content across, and then close. So let's try and recompile that. Copy fstream.cpp, and I'm just going to call my executable copyf. Now, for us to actually try this out, we should have a file that we want to make a copy of. So I'm going to do that with my test file here. So I just took my editor and I just threw a bunch of text into my test file. So anything you like, right? Just to have something that we can make a copy of here. So what we'll try is to run our copy file program. So run copyf. It'll ask me for the names of the files. So I want to make a copy of test file. And let's call it my new file. So this should hopefully be creating a new file and writing the contents of test file into it. All right, so in theory, this went through and character by character, and it didn't complain, it didn't give me any error messages, it tells me the copy succeeded, so it thinks it worked. Let's show the contents of our test file and show the contents of new file. And yeah, it does actually look like it copied each of the lines across successfully. So we can do this kind of character by character copy. All right, I want to do one more example here, and then maybe we'll leave it. So for this one, I'm going to go through a file line by line and show the contents of the file. So we'll call this one showlines.cpp. And so for this one, I'm going to do it a little differently as well. So for one thing, when I do the reading, I'm going to read line by line using getLine instead of the character by character one that I just did. And the other thing is, this time, just to show you that you can pass these things by reference, I'm going to have the main routine open the input file and then pass that opened input file, the ifstream variable in file, to the function and let the function work with something that's already opened. So the showlines function is never going to know what the name of the file is. It's just going to get this opened ifstream variable. Now, you do want to make sure that this is passed by reference, because again, there's information inside there that tracks where it is in the file and what the current state of the file is. So you want to make sure that when this returns, main gets kind of the updated information. So whenever you're doing this, you want to make sure you pass these things by reference. So showlines is going to go through, check to make sure that the file is actually opened, so it's going to run that isOpen to check. And as long as that's okay, it's going to go through and read the contents line by line and just display them on the screen for us. So same sort of idea, enter the file name, we'll read it into a string, and I'm going to have the main routine create my ifstream variable. I'm just going to call it infile again, and try and open it. So we'll do our open and whatever the file name is, and then we'll pass that infile stream, that ifstream variable infile, to showlines and let it work with it. And then as far as the main routine is concerned, we need to make sure that we opened it, so we should close it, but we'll just double check and make sure that it was actually opened before we close it. And the only reason I don't have the showlines inside there is because I want to show us actually checking inside showlines for whether this worked or not. So in show lines, just to be safe, it should always make sure that the file is actually opened. Okay, we should actually check. Sorry, I should check if that's open, not if it failed. So let's check if the input file is open. And then I'm going to go through, and while I'm not at the end of the file, I just want to show a while loop instead of a do while this time. So if the in file opens successfully, we'll try and look at the contents. Otherwise, we'll give a message, couldn't show the content, the file wasn't open. And again, while we're not at the end of the file, I'm going to use getLine to read the next entire line of the file. So I'll have my string variable, I'm going to call it next line, and I want to read from that ifstream variable, inf here, into my string. And again, if that didn't realize that we were off the end of the file, then we'll print out whatever that line is. So this should, line by line, show me what the contents of the file were, quitting when we eventually hit the end of the input file. All right, so let's see if that actually works. So again, we'll try compiling this beast. And seems to have compiled okay. So let's run this and we'll just show the content of test file, for instance. And again, it should, oops, sorry. Not a command line argument, I want to read this in. Getting ahead of myself. So it asks us for the name of the file, we type it in, and it goes through line by line and shows us the content. So it does appear to be working okay. Now, again, in terms of error checking, suppose I gave it the name of a file that didn't exist. Oh, good grief, I'm doing it again. Enter the file name, foo. And again, our show lines function realizes that foo wasn't open, right, because the file didn't actually exist. So we can do our error checking and see if we're successfully managing to open these files before we do things with them. All right, I think that was everything I wanted to go through with this for the moment. Next time we'll go through and use the C standard I/O approach to this. Similar sort of idea, open the file, check that it worked, and then do whatever input or output you want to do and close it up again. But that should give us a good basis for now working with files instead of with the keyboard and monitor if we want to.